Alright, in this video we're going to look at how to decompose into partial fractions when we have got repeated linear factors. Let's look at an example. The principles of how to do this were established in a video entitled Partial Fraction Decomposition Part 1. You might want to check that video if you haven't already done so. Okay, so in this example, just looking at this rational function, the numerator is of degree 1, the denominator is of degree 3, so this is a proper rational function. So we can go ahead and factorize this. So when we do that, so we just need to factorize the denominator. So common factor is x squared, then it's going to be x squared into 2. Then we notice that x squared is a repeated factor, and then something that we mentioned in an earlier video is that if you've got a repeated factor like this one is repeated twice, it means it's got two factors in there. The first one is x, and then the second one is x squared. So those are two different factors. So for each of them, we're going to have a partial fraction. The other thing we mentioned is that if the denominator is a cubic, then we can expect that the unknowns in the partial fraction decomposition will be 3. So in this case, we're going to have a over x plus b over the next factor is x squared, and then c over x plus 2. Okay, then if we multiply everything by this denominator, this is what is going to happen. So on the left hand side, we're going to be left with just the numerator, and on the right hand side we're going to have ax times x plus 2. Then the second term is going to be b into x plus 2. Then the third term is going to be c times x squared. Then we are going to plug in the roots of this denominator. It's only going to be 2 roots because one of them is repeated. So associated with this factor, we're going to have x equals to 0, and then associated with this factor, we're going to have x is negative 2. So notice that we have got 3 unknowns, but we'll show you how we're going to handle that. So plugging in x equals to 0, on the left hand side it's going to be negative 1. This term is going to disappear. This term is going to be 2b. This term is going to disappear as well. So that means b is going to be negative 1/2. Then the other root is negative 2. We plug in negative 2 on this left hand side, is going to give us negative 5. Then this term is going to be 0, this is going to be 0, this is going to be 4c. So this is telling us that c is negative 5 over 4. Then a is still undetermined. Okay, so what we can do is remember we said this equation is going to be true for any value of x. So we can choose any other number which is not one of these two. Okay, so for instance, I'm going to plug in x equal to 1. So when x equals to 1, the left hand side is going to be 1. This term is going to be 1. That's going to be 3. So that's going to be 3a. That's going to be 3b as well. That's going to be c. So plus 3b plus c. However, b and c are already known, so that means from this we can substitute and just find a. So this is going to be 1 equal to 3a. This is going to be minus 3 over 2 minus 5 over 4. Then if we solve this for a, we will find that a is 5 over 4, and so our calculation is done. So we're just going to substitute a, b, and c here. So this is what we're going to have. So 2x minus 1 all over x cubed plus 2x squared is going to be 5 over 4 over x minus 1/2 over x squared minus 5 over 4 over x plus 2. There's a common factor of 1 over 4. So if we take that one outside, then this is just going to be 5 over x minus 2 over x squared minus 5 over x plus 2. Right, so that sorts out that example. In the second example, imagine we have 3x squared minus 4 all over x cubed minus 4x squared plus 4x. So again, this is going to be proper because the numerator is of degree 2 while the denominator is of degree 3. So that means we can go and straight away start factorizing the denominator. So if we do that, we're going to have x is common in the denominator. So it's going to be x into x squared minus 4x plus 4. And then we can factorize that further. It's going to be x into x minus 2 all squared. So that means this is the repeated factor this time. So there are two factors there. So we can write this into partial fractions. It's going to be a over x plus b over x minus 2 plus c over x minus 2 all squared. So two partial fractions from this term here. Then if we multiply everything by this denominator, then we can clear the fractions. We're going to have 3x squared minus 4 is equal to a into x minus 2 all squared. Then we're going to have bx into x minus 2, and then the last term is going to be cx. There are only going to be two roots because one of them is repeated. So one of them is going to be 0 from here, and then the other one from here is going to be 2. So if we plug in x equals to 0, left hand side is going to be minus 4. This is going to be 4a. This term is going to disappear, and this one is going to disappear. So this is going to be a equal to negative 1. Then after that we plug in x equals to 2. If we plug in x equals to 2, the left hand side is going to be 12 minus 4 is 8. The first term will be 0. This will be 0, so that's going to be 2c. So that tells us that c is going to be 4. We are now out of roots. We've run out of roots, but we can use any other number. We use x equals to 1, any other value of x. So when x equals to 1, the left hand side is negative 1. This is going to be a, this is going to be b, this is going to be c. And then we already know that a is negative 1, c is 4. So this is telling us that b is going to be negative 4. Therefore our rational expression 3x squared minus 4 over x cubed minus 4x squared plus 4x is going to be equal to, a is negative 1, so negative 1 over x, c is negative 4, sorry, b is negative 4, and c is 4, so plus 4 there, x minus 2 all squared. And so that is that. Let's give you just one to try. So you can pause the video while you have a go at this. Let's make this 4x plus 3. So in the denominator we've got x cubed plus x squared minus x minus 1. So we would like to decompose this or resolve this into partial fractions. Alright, we are now going to show you the solution to part C, which is like 4x plus 3 over x squared, sorry, x cubed plus x squared minus x minus 1. So here is our solution. So first thing we note is that this is a proper rational expression, so there's no need to divide first. So we go into factorizing. This can be factorized by grouping, which we are going to use here, but you could use your rational root theorem, and synthetic division is going to give you the same thing. If you're not up to speed with those, you can check our videos. Right, so we group the first two terms and the last two. Then there's a common factor of x squared here, and then now x plus 1 is common. There's a difference of two squares, so this is going to factorize into x plus 1 times x minus 1. So x plus 1 is going to end up being a repeated factor, and so we set up the partial fractions like that. Multiplying through by this clears out the fractions, and we're going to have that. There are going to be two roots for this, minus 1 and plus 1. You plug in 1, you get c is 7 over 4. You plug in negative 1, you get b is 1/2. Then a is still undetermined, so we can choose any other value. In this case we've chosen x equals to 0. You can actually confirm that even if you choose any other value of x here, it's still going to give you the same value of a. And then we plug these into this setup here, and so those are partial fractions, and that is the final answer there. All right.